All right, everybody, I'm Jacob, and this is the first lab for 2212. So, first of all, this lab is a comparison between two models, and it's all going to be due to suspension of one tape due to an electrical force. My hypothesis was that the different models that we create will be similar, um, and we'll be able to use assumptions in computation to generalize our information about the physical experiment. So the two things we need for this are Coulomb's law and Newton's second law. Newton's second law is a proportion between sum of forces and acceleration on an object, and Coulomb's law is electric field forces, basically. So our two models, we had firstly an experimental model, which is where we stuck tape on a table, put another layer of tape on top of it, and rip that off. That would create a positively charged tape because, well, how do we know it's positive, I guess? We took a plastic pen, rubbed it in our hair, and hang it next to our charged tape that we just ripped off the table, and they would attract each other. And we know that when we rub a pen in our hair like that, it'll take some of the electrons because the plastic is more electronegative than our hair, and therefore it'll take some of the electrons. And now we have a negatively charged pen. And if the tape and the pen are attracting each other, they have opposite charges. So therefore, we know our tape's charged. And then we would hang one of these tape like a rope bridge and pull another tape under it, and they would repel each other. And we could suspend that sort of like a, if we were to suspend the rope bridge in the air. Then using glow script, I made 2-point charges, hang them at the same exact height that we measured in the experiment. And then we could use this to calculate sort of information about our experiment. So here's the actual experiment. You can see in the image on the left it's sort of dangling, and the image on the right is sort of hanging a little bit. And then here's what our function code will look like, and it'll kind of just pause here. This is sort of always what our thing will look like. Stuff code. But these are the important parts. I'll sort of show you them in the actual thing here. Our initial values are half of the code. So we have our k value, we have our calculations, we have our initial velocity, our t values, our mass, our gravity, all that stuff. Then we need our electric field. Check our electric field here. This is basically, this is just Coulomb's law written out into glow script. And then our position function, or our sort of while function, our iterative analysis, will sort of analyze the force at tiny time steps of t. And we can sort of model the motion of our 2-point charges. So this is what it looks like running. As you can see, the purple charge isn't moving, which is exactly what we want. All right, and then coming back here, we can talk about our results. So our y position of the tape, since it's suspended and not moving, we know the acceleration equals 0, and that's because, well, we have a lack of acceleration in y direction. And if we go back to our Newton's second law equation, we know that acceleration equals 0, force equals 0. So then to calculate the sum of forces, we need to check out our system and our surroundings. So our system is the tape that's hanging, and our surroundings will be the tape on the bottom, as well as we need to make sure that we account for the force that gravity is applying on our top tape. So then to calculate these magnitudes of forces, we know that gravity is just mg, and we know that our electric force is kq over d squared. We know m, we know g, we calculated the m. We know k is a constant, we know d, we measured it, so all we need is qq, and we're creating the tapes in the same fashion. So we know that our total charge and the square root of that will be our individual charges. And that's this value right here. So the square root of this will be our individual charge. All right, and then the lab questions we can go ahead and talk about. What if the electrons had positive charge and protons had negative charge? So what if they swapped sort of definitions? This wouldn't alter any of the observations we had in the experiment. It also wouldn't alter the way we found out how our tape was positive, because if they switched, then the electrons that went onto the pen would not be positive, and the lack of electrons on our tape would be negative, and they would still attract. So this really wouldn't change anything between our objects. I guess at the molecular level you would notice a difference, but our two tapes would still repel each other, and our pen and our tape would still attract each other because they do have opposite charges. What does it mean? Why do we care if we handle the tapes a lot or a little? Well, if we imagine the tapes with a positive charge, this means they have a lack of electrons. And if our skin is very neutral, so then if we go ahead and touch our tape, it's going to try and balance that out by sort of taking some of our electrons. The tape will take the electrons, and then in that case, it'll lose some of that positive charge or lack of electrons because it just stole our electrons. And if we lose our sort of charge on the tape, what's the point of the experiment? So we're decreasing our charge, we're going to have less reaction. And that's it. Thank you very much.